Hello, AP Chem students, and welcome to topic 5.7, Introduction to Reaction Mechanisms. The learning objective for today is 5.7.a, Identify the components of a reaction mechanism. Now, I have to front load this and tell you that I think this is one of the more accessible parts of the AP Chemistry exam because, at least at our level, a lot of the components and mechanisms are pretty cut and dried. And so that makes them feel comfortable to us when we take the exam. So this is a good section for you to gather some points and improve your score. So as previously stated, a reaction mechanism is a series of steps through which a reaction proceeds. In order for a reaction mechanism to be valid, it must satisfy two requirements. The first requirement is that the elementary steps must combine to give the overall reactions. In other words, all of the reactants must sum to give the reactants for the overall process, and then all of the products must sum to give the products of the overall process. So for the reaction, NO2 yields plus CO2 yields NO plus CO2. You can see here that our NO2s on both sides will cancel out, one of them, and then we have an NO3 on both sides that will cancel out. And so then we are left with our overall reaction, which is NO2 plus CO yields NO down here plus CO2. Okay, so then somehow we inadvertently left off, I believe, the second requirement for the valid mechanism will be discussed in topic 5.8. Okay, so some special vocabulary exists for reaction mechanisms. And so to help with the vocabulary, I'm going to continue using this reaction mechanism that I showed you on the previous slide. So this is between nitrogen dioxide and carbon monoxide, which forms nitrogen monoxide and carbon dioxide. So there it is. So an intermediate is a species that is formed in an early step and then consumed in a later step. So it's there, but it's only there as long as the reaction is actively occurring and it is all consumed by the end. So in the mechanism shown below, NO3 is the intermediate. And this can be figured out, there it is, from the reaction mechanism because it is a product in an early step and then it is a reactant in a later step, and therefore it cancels out. Okay, so then now this should say catalyst. Let me pause. Okay, so catalysts are species that speed up a reaction but are not consumed in the reaction. And so sometimes we do see that they are consumed in one of the steps, but then they're produced in a later step. Other types of catalysts are always there, and that's usually something like a surface catalyst, like platinum. So sometimes platinum is added to just provide a surface for the reaction to take place on. So in the mechanism shown below, NO2 is the catalyst. And we can tell this because it is an early reactant and then a later product. Okay, so you can see it there is an early reactant and then it is a later product. We're going to talk more about catalysts at the very end of Unit 5. So that's it. So what should I be able to do with this? Well, you should be able to label the components of reaction mechanism, the reactants and the products, of course, and then intermediates and catalysts. And then you should be able to determine if a provided reaction mechanism is valid for the given reaction. And we've done one part of that today in this video by looking at the overall stoichiometry of the mechanism must match the stoichiometry for the process overall. And that is all, and I will see you soon for our next topic, which will be 5.8.